Jai Hind students, myself Dr. Meenakshi Sinha from Ajay Kumar Garg Engineering College, Ghaziabad. Today I am here to present the video for the topic multiple integrals, which is unit 4 in the Engineering Mathematics 1, which is for BTech first year students. So in this topic, the subtopic which I consider in this lecture is the Dirichlet integral and its application and the Liouville's extension of Dirichlet integral. So this Dirichlet integral is a very important topic in multiple integrals. Why this is very important? Because when you evaluate the double and triple integrals, so you need the limits. So by this Dirichlet integral, we able to evaluate the double and triple integrals without putting the limits directly with the help of gamma functions. Okay. So look at what is the Dirichlet integral. Dirichlet integral says, first I am taking the theorem for double integral. If L, M and R all positive, then the integral double integral over d x to the power L minus 1 y to the power m minus 1 dx dy is gamma L gamma m upon gamma L plus m. So here we are using the gamma function to evaluate this double integral. So what the meaning? That no need to put the limits over here for x and y. Just directly convert this into gamma function into a to the power L plus m. So where what is this d? D is the domain x greater than equal to 0, y greater than equal to 0 and x plus y less than equal to a. So only under this domain we able to apply the Dirichlet theorem. So if we look at what is this domain, if I try to draw this on this x greater than equal to 0, y greater than equal to 0 means the first quadrant, and the line x plus y equal to a is this line, is the line x plus y equal to. So means the Dirichlet theorem is applied only for that part of the curve which is lying in first quadrant, which is lying in the first quadrant, positive quadrant, which is lying in the first quadrant. So this is the condition to apply Dirichlet integral, that this gives you the value of the integral only for that domain which is lying in the positive quadrant, in the first quadrant, this one. So this is the Dirichlet integral expansion for the two variables, for double integrals. Look at for the triple integrals, if L, M and R all positive, then the integral, triple integral over the volume V, x to the power L minus 1, y to the power m minus 1, z to the power m minus 1 dx dy dz is gamma L, gamma m, gamma n by gamma L plus m plus n plus 1, where V is the reason, x greater than equal to 0, y greater than equal to 0, z greater than equal to 0 and x plus y plus z less than equal to 1. If again I try to draw this reason in the 3 dimension, this is x axis, y axis and z axis. So x, y, z all are taking the positive values only, and x plus y plus z less than equal to means this is the one intercept, this is 1, this is 1. If I join this, so I am getting this plane. So means for 3-dimensional also, the reason here is only the part of the surface which is lying in the positive octant. So what is the meaning? That to apply Dirichlet integrals, the condition is that it gives only the volume or area or the double integral, triple integral only for that part of the curve which is lying in positive octant. So means if I need to find out the volume, suppose for the full surface, so I have to multiply. I first find out the volume for the positive octant by using this Dirichlet integral and then multiply that volume by 8, because if I divide my 3-dimensional figure into number of octants, so here we have total 8 number of octants, like this one. So this is our Dirichlet integral, which is very important topic for multiple integral. So directly I am coming to the examples for this Dirichlet integral. Right on the first, look at the first example, the plane x by a plus y by b plus z by c equal to 1 meets the axis in ABC. Apply Dirichlet integral to find the volume of tetrahedron OABC. Also find the mass if the density at any point is rho equal to kxyz. So here in this question, we have to apply Dirichlet, we have to find out the volume and the mass by using this Dirichlet integral. And for calculating the mass, the density is also provided to you, which is a function of x, y, z. So to apply the theorem, first I need to satisfy my defined domain. To define this, find out that defined domain, I need to convert first this plane into some linear value. So for that, what we start with, I start putting x by a equal to u, y by b equal to v, and z by c equal to w. Here, putting these as u, v, and w, what we get the domain over here, look at, then u is greater than equal to w, v greater than equal to 0, w greater than equal to 0, and u plus v plus w less than equal to 1. And which is the required condition, which is the required positive octant for the Dirichlet integral, for the application of Dirichlet integral. So by putting these substitutions, we able to convert this to a domain which is applicable, on which we can apply the Dirichlet integral over here. Clear? So after this, writing the value of x in terms of u, we get x equal to a into u, y equal to this b into v, and z equal to c into w. And taking their differential, I get that dx equal to a into du, dy equal to b into dv, and dz equal to c into dw. So the first step to solve the questions for Dirichlet by Dirichlet integral, that whichever plane or figure you are provided, first you convert this into some linear values by putting this first value as u, the second one as v, the third one as w, getting the value of x, y, z in terms of u, v, w, and then taking the differential, I write down the value dx, dy, dz over here in terms of du, dv, dw. So now we start finding the volume for this given tetrahedron. So look at the next, by Dirichlet theorem, what we have? We know that triple integral v, this is the definition of Dirichlet, which we have learned in the first slide. X to the power L minus 1, y to the power m minus 1, z to the power n minus 1, dx, dy, dz is gamma L m n upon gamma L plus m plus n plus 1, where v is this defined domain. So when we have converted in our question x, y, z to u, v, w, then we are getting the same domain over here, which is satisfied. So now starting with the same, this we have done in the last slide, writing the value x, y, z in terms of u, v, w. So start writing the volume over here. What is the volume? The formula for volume is triple integral dx, dy, dz. So now what I need to do, I need to convert this integral in the form of du, dv, dw in the terms of new domain. So putting their values, I start solving this triple integral. I put the value dx here is a into du, into dy here is b into dv, and dz is c into dw. So now taking the product, a, b, c are constant here, which we can take outside the integral sign. So this is nothing but a, b, c triple integral du, dv, dw. So now I need to solve it by using Dirichlet integral. So I compare this with the left hand side of Dirichlet integral. So I need to write this integral in this form. Now since the power of u, v, w are missing here, so I can write this as ABC triple integral u to the power 0, v to the power 0, w to the power 0, du, dv, dw. We can write it like this. And 0 I need to write in the form L minus 1, m minus 1, n. So in the next step, I can write this as ABC triple integral u to the power 1 minus 1, v to the power 1 minus 1, w to the power 1 minus 1, du, dv, dw. 0 is always written as 1 minus 1. Or you can, what is the easy? You can add 1 over here in this power and subtract 1 from here. So we get the value 1 minus 1 with each. Now if I compare this with the left hand side part, so here the power is x to the power L minus 1, here the power is u to the power 1 minus 1. So comparing with the left hand side, what we get that L is equal to 1, m is also equal to 1, and n is also equal to 1. So when I get the value L, m, n, And here the domain for Dirichlet is satisfied. So directly writing its value by using this gamma function. So L, M, N each here are taking the value 1. What is the value? This is A, B, C. I can write gamma 1, gamma 1, gamma 1 upon gamma L plus M plus N plus 1. So it will become 1 plus 1 plus 1 plus 1 is the value. Solving it, I hope you know that gamma 1 is always 1, and in denominator we get the value gamma 4, and gamma 4 is nothing but written as 3 factorial. Gamma 4 is written as 3 factorial. So this value will become nothing but ABC divided by 6. So this is the volume. Look at volume of the tetrahedron. We are getting ABC divided by 6. This is by using the Dirichlet integral. So what is the application mean? Ki if I not apply the Dirichlet over here, so what I need here? I need here the limits for UVW from the given domain. You convert this limit, put the limits over here, and then evaluate it by classical integration method. But by using the Dirichlet, I directly converted this to the left hand side of Dirichlet and getting the value of LMN converted in the form of gamma function and writing its direct value ABC upon 6. So the first part of the question, finding the volume of the given tetrahedron. Coming to the second part, in the next part we need to find out the value mass. So again we are using the same values for x, y, z, dx, dy, dz which we have taken initially, and the mass. Mass, we know that it's triple integral density into dx, dy, dz, and this density value is given to us as kxyz. So putting the value density, so this will become triple integral kxyz into dx, dy, dz. This is the value. Now what I need to do, I need to convert this integral in the form of UVW and du, dv, dw. To put the values of xyz, dx, dy, dz in terms of uv and w. So start solving. Look at k here is constant. We can take this k outside the integral, this triple integral. Look at xyz. X is replaced with a into u. Y is replaced with b into v. Z is replaced with c into w. Into dx, dy, dz. Dx is nothing but a into du. Dy is b into dv. And dz is c into dw. So we have replaced each and every value x, y, z by the value u, v, w in terms of. Now combining the constants over here, it's a, b, c, and this is also a, b, c, which will give you the value a square, b square, c square. Taking that outside integral, I can write this is k, a square, b square, c square, and this is triple integral. What we left? U into v into w into du, dv, dw. This we are getting. Now, again, if I look at the definition of Dirichlet integral, so in Dirichlet integral, I need to write these parts in the form L minus 1, M minus 1 and N minus 1. Clear? So here the power is 1, u to the power 1. What I do to write it as in the form L minus 1? I add 1 to this and subtract 1 over here. Similar, the power of v is 1 over here. The best way to add 1 over here and subtract 1. Here also the power is 1, we add 1 and subtract 1 for this. So if now you look at, this is of the form u to the power 1 plus 1 is 2 minus 1, v to the power 2 minus 1 and w to the power 2 minus 1. So comparing with the definition of Dirichlet theorem, what we get the value LMN. L here is also 2, M is also 2 and N here is also 2. So condition for Dirichlet is satisfied. Domain, we are already chosen that domain which is satisfied by the Dirichlet. So directly apply the Dirichlet integral over here. So but I write this as k a square b square c square. You can write k a square b square c square into L, M, N each here taking the value 2. So I can write this gamma 2, gamma 2, gamma 2 upon gamma 2 plus 2 plus 2 plus 1. Gamma L m n upon gamma L plus m plus n plus 1. What is this on solution? This is nothing but k a square b square c square gamma 2 gamma 2 gamma 2, they are nothing but 1 factorial, and we know that 1 factorial for each gamma value taking the value 1 upon 2 plus 2 plus 2 plus 1. This will become gamma 7. Solving this, I write this is k a square b square c square into 1 upon gamma 7 is nothing but 6 factorial. And when you open this 6 factorial, we get the value of the integral as this, not seen over here. This is k a square b square c square upon 720. So this is the mass which I am getting over here, k a square b square c square by 6 factorial, which is k a square b square c square by 720. So this is how we apply the Dirichlet integral, and main application of Dirichlet is to find out the volume and mass. You can apply Dirichlet integral to solve any of the triple integral, but only for that part of that in which is lying in the first octant, in the positive octant. Clear? So the first example to find out the volume and mass, look at the one more example. For the next one, apply Dirichlet integral to find the volume and mass. Again, you have to do the same, volume and mass of the positive octant. This is already given to us. Of the ellipsoid, x square by a square plus y square by b square plus z square by c square equal to 1. The density at any point is given as, rho is the notation for density, rho equal to k x y z. So the density is given, we have to calculate volume and mass, and positive octant is already provided here. So if the positive octant word is given in the question, means already this ellipsoid, you have to find out the volume of that part of ellipsoid which is lying only in the positive octant. So we can apply the Dirichlet integral over here. But before that, what we need to do, we need to convert this into a domain which satisfied by the Dirichlet. So for that, we start putting this value equal to u, this value equal to v, and this value equal to w, such that it can be converted to some linear value. So starting the solution, we start putting x square by a square equal to u, y square by b square equal to v, and z square by c square equal to w. So the first step. In the next step, we start writing the values of x, y, z in terms of u, v, w. So in terms of u, v, w, we get the value x equal to under root u. It means if I start solving, if I start the value x square by a square equal to u, I get x square is equal to a square into u. Taking the square root, this is x will become a under root u. So the first value a under root u, y will become similarly b under root v, and z similarly becomes c under root w. After getting this x, y, z, just take their differentials. So dx will become, if I take its differential, so what is dx? This is a, this will become a into u to the power half. If I take its differential, so this is a into 1 by 2 into u to the power minus half into du. And this u to the power minus half taken over here, right, written in the form a by 2 under root u into du. This is the value. Similarly, we get b, dy equal to b by 2 under root v into dv, and dz is equal to c by 2 under root w into dw. This is the value. Clear? So after converting x, y, z to new functions u, v, w, and dx, dy, dz to some new function du, dv, dw, what we have seen now, the domain which we are getting now in terms of u, v, w, I look at, I erase this. The domain which we are getting in terms of u, v, w, we are getting the value something like of the form, this one. I get u greater than equal to 0, v greater than equal to 0, w is also greater than equal to 0, and u plus v plus w less than equal to 1. This is my domain for these new values u, v, w, because already you are provided that you are working in positive octant. So if x, y, z are greater than equal to 0, then obviously UVW also must be greater than or equal to 0. And by putting this x square equal to u, y square equal to v and z square equal to w over here, I get the value u plus v plus w less than or equal to 1. So this is the domain which is satisfied by the Dirichlet integral. So we can apply Dirichlet over here to calculate the volume and mass. Now we first starting with finding the volume over here. As you know that volume is given by triple integral dx dy dz. This is the volume. Triple integral dx dy dz. So now putting the value dx dy dz, which we have already calculated in terms of du dv dw. Just put their values, but we get, look at triple integral. The first value is a upon 2 under root u. The second value is b upon 2 under root v. The third one is c upon 2 under root w. And combining these du dv dw in last. Du dv and dw. That's the value. A by 2 under root u plus b by 2 under root v plus c by 2 under root w du dv dw. Now combining the constants, we can take it outside the integral. In the numerator we got ABC. In denominator 2 into 2 into 2 become 8. So I am writing ABC by 8 outside the integral. Look at now what we get inside. It's triple integral. 1 by under root u. Shift it to numerator, raising it power to minus half. Similar, it's 1 by under root v. Shift it to numerator, raising again its power to minus half. 1 by under root w written as w to the power minus half into du dv dw. Finally, what I need to write these parts in the form L minus 1, something m minus 1 and n minus 1. For that, I have already discussed that the first best way is to add 1 to this power and subtract 1 over here. In the next bar also add 1 over here and subtract 1. In the next also add 1 over here and subtract 1. So by adding and subtracting 1, these parts look in the form L minus 1, m minus 1 and n minus 1. And what are each element? Minus half plus 1 is plus half. So each L, m and take the value plus half over here. So directly applying the Dirichlet integral, ABC by 8 is outside the integral into what we get, look at, it's gamma half, L is also half, gamma half, each L, m and r half divided by gamma half plus half plus half plus 1 is the value. Gamma L plus m plus n plus 1. Okay. What is this? ABC by 8, I try to solve it. Gamma half. You have already studied the gamma function. Gamma half value is nothing but under root pi. So it will become under root pi multiplied by under root pi into under root pi. So multiplication of all these gives you the value pi under root pi. And what we get on denominator after adding them? Half plus half is 1. 1 plus 1 is 2. And 2 plus half will become gamma 5 by 2. So on solving this, I am getting the value I am writing over here. This is gamma 5 by 2. Sorry. We get the value gamma 5 by 2. Okay. I can write over here gamma 5 by 2. This one. And finally, to evaluate this, I need to find out the value for this gamma 5 by 2. So by the reduction formula, we know that I can write this as, I am writing over here, it's ABC upon 8. In the numerator, I have pi under root pi. And how we reduce this gamma 5 by 2? By the reduction formula, this is nothing 3 by 2 into 1 by 2 into gamma half, which is again written as under root pi. So to solve the questions by using Dirichlet integral, already you have the prefix knowledge of these gamma functions. How to reduce these gamma functions like this one. Now solving this, 2 to the 4. This will cancel out, giving you the value 2 over here. This under root pi will cancel out. So what I left with? I left with the value ABC. In the numerator, I have pi upon 3 to the 6. So ABC pi upon 6 will now become the volume of this given ellipsoid. And this volume is calculated only for that part of the ellipsoid which is lying in the positive octant. Clear? So this is how we calculate the volume. It's ABC pi divided by 6. This is the answer for this. Yeah. Now coming to the second part. In the second part, we need to find out the mass by using this density. Yeah. Using the same values which we have initially done, writing the value x, y, z in terms of u, v, w and dx, dy, dz. So look at what is mass here. We have already discussed the mass is given by triple integral density dx, dy, dz is the value. Putting the value density, which is the function of x, y, z given over here, triple integral, the density is k x, y, z dx, dy, dz. We know that what we have to do next, we have to replace the values x, y, z and dx, dy, dz by using these values in terms of u, v and w. Put the values. K I am taking outside the integral. Look at what we get. In place of x, we get a into under root u. In place of y, we get b into under root v. In place of z, we have c under root w. So multiplying the constants, I can write this a, b, c under root u, under root v and under root w. I can write it like this. Next is the value dx, dy, dz. Replace these. Dx is a by 2 under root u. I can write a by 2 under root u. Dy is b upon 2 under root v. And dz is c upon 2 under root w. And finally we have du, dv, dw like this one. So we keep the values x, y, z and dx, dy, dz over here in terms of u, v and w. Now look at what's happening over here. This under root u in numerator and denominator both will cancel out. This under root v also cancel out. This under root w will also cancel. So each power of under root u, under root v, under root w cancel out over here. What we left? Now we left only with the constants a square, b square, c square divided by 2 to the 4 to the 8. That I am writing outside the integral. I write this k, a square, b square, c square by 8, and inside the integral what I left only with du, dv, dw. I write only with du, dv, dw. But finally I have to write this in the form of x to the power, means u to the power l minus 1, v to the power m minus 1. But here if I look the powers of u, v, w, so each u, v, w are missing here. So I can write u to the power 0, v to the power 0, w to the power 0. And finally, this is nothing but written as k a square, b square, c square upon 8 triple integral. 0 is written as again 1 minus 1, 1 minus 1 and w to the power 1 minus 1 du, dv, dw. Right. This is the value. So we are getting here the value L, M, N which are each 1, 1, 1. Solving it by Dirichlet integral now, this is nothing but k a square, b square, c square upon 8, each element taking the value 1 here. So what I write by Dirichlet, it's gamma 1, gamma 1, gamma 1 upon gamma 1 plus 1 plus 1 plus 1, which is gamma 4 in denominator. Now just solving it, gamma 1 we know that its value is always 1. It's k square, b square, c square upon 8, 1 upon, this is gamma 4, and gamma 4 we know that it's 3 factorial. 3 factorial means 3 to the 6. So this will give you the value 6 and here it's 8. 8 6 is 48. So if I multiply, I am getting the mass as k a square, b square, c square by 48. This one. So this is the mass which we are getting over here, k square, b square, c square by 48. Clear? So this is how we apply the Dirichlet integrals to solve any, in place of volume and mass, if you have given here any of the triple integral, but only for that part which is lying in the first octant. You can find out, you can able to solve that integral by using the Dirichlet integral. So the first integral which is called the Dirichlet integral. In the next slide, we are discussing about its extension, means the extension of Dirichlet integral, and that extension is known as Liouville's extension. So in the next slide, we are discussing the Liouville's extension of Dirichlet theorem. This is the extension of Dirichlet. Look at what it says. If the variables x, y, z are all positive, such that h1 is less than x plus y plus z is less than h2, means the limits for x plus y plus z are given here from some h1 to h2 over here. Then what it says? Triple integral function of x plus y plus z, x to the power l minus 1, y to the power m minus 1, z to the power n minus 1 dx dy dz is gamma l, gamma m, gamma n upon gamma l plus m plus n. Please note that here we don't write the value plus 1 just like the Dirichlet. Here is only l plus m plus n. Integral h1 to h2 f of u. Here the function is x plus y plus z. F of u means I kept this x plus y plus z, I transform this into a single variable u over here, into u to the power l plus m plus n minus 1 into du, into u to the power l plus m plus n minus into du. So what this extension is doing, this extension is converting a triple integral into a single integral by again using the gamma function. So what I need the limits of this x plus y plus z, put the limit over here from h1 to h2. Function of u means keeping this x plus y plus z equal to some u, into u to the power this l plus m plus n minus 1 into du. So after using this extension, we able to convert the triple integral into single integral. Just we evaluate this single integral, use the value of gamma functions over here. So we try to evaluate this integral. So this is known as the Liouville's extension of Dirichlet theorem. Now directly I am coming to the examples for this extension. Look at the first one. Evaluate triple integral log x plus y plus z dx dy dz, the integral being extended given to all positive and 0 values of x, y, z subject to the condition x plus y plus z less than 1. Clear? Means the upper limit 1 is given to us here. What about the lower limit? Means I need to find out the values h1 and h2. For the lower limit, you are provided that x, y, z all are taking the value 0, positive and 0 values. So what must be the lower limit? Lower limit must be the value 0 over here, because x plus y plus z, each and every not going to take any of the negative values over here. So this is 0 less than equal to x plus y plus z less than 1. So I need to evaluate this integral. We apply the Liouville's extension to evaluate it. Okay. So what we got here, 0 less than equal to x plus y plus z less than 1. This is the definition of Liouville's extension. We know that by Liouville's extension, it's moved in the next step. I know that this f of x plus y plus z into x to the power l minus 1, y to the power m minus 1, z to the power n minus 1 dx dy dz. This is given by this formula which we have discussed in the last slide. Gamma l, gamma m, gamma n upon gamma l plus m plus n integral h1 to h2. Function of u means keeping this x plus y plus z equal to u into u to the power l plus m plus n minus 1 into du. Yeah. So now we start applying this extension to solve this given integral. Clear? So now we are starting with this given integral, triple integral log x plus y plus z dx dy dz. Now look at how we evaluate it by using this extension. Clear? So first of all, I need to write this given integral in same as the left hand side of this extension. The function of x plus y plus z given here is log x plus y plus z. What I need next? X to the power l minus 1, y to the power m minus 1, z to the power n minus 1, which is missing here. Means here the value of x, power of x is 0, power of y is also 0 and power of z. So what I write this as triple integral log x plus y plus z into x to the power 0, y to the power 0, z to the power 0 into dx dy dz. I can write it like this. Because they are missing parts, so I write it as 0, 0, 0 part. This is nothing but triple integral log x plus y plus z into x to the power 0. I need to write this in the form L minus 1, M minus 1, N minus 1. So 0 written as 1 minus 1, y to the power also 1 minus 1, z to the power also 1 minus 1, dx, dy, dz. And if you look at now, this is similar as that of the left hand side of Liouville's extension. So we can apply the extension over here. I am writing this by using this right hand side part now. If you consider what is L, M, N each here, each element here take the value 1, 1, 1. The similar as that of the Dirichlet we have done. So L, M, N are the value 1. So applying the theorem, the first step, I have to write gamma 1, gamma 1, gamma 1, each are 1 here, upon gamma L plus M plus N. Plus 1 is not over here, which is we have used in the Dirichlet integral. It's L plus M plus N plus 1. In Liouville's, please remember it's only L plus M plus N in denominator. Okay. Next is integral H1 to H2. H1, H2 are limits of x plus y plus z. Here the limit given as 0 to 1. So integral 0 to 1. F of u. F of u means whatever is my function. In place of x plus y plus z, I have to take this equal to some u. So in place of u, suppose I take the value as t, suppose here. So I write it as f of, or you can take u also, f of u, take it as u, into u to the power L plus M plus N minus 1. I know each L, M, N are 1 here. So I write this is into u to the power 1 plus 1 plus 1 minus 1 into du. So that's how we use the extension over here, converting this triple integral into a single integral. What happened to the part? This plus 1 minus 1 cancel out. So this is nothing but putting the value function of u also, where the function here is log x plus y plus z. What will become this? This is gamma 1 means 1 in numerator. In denominator it's gamma 3. Gamma 3 is nothing but 2 factorial, which is again written as 2. Integral 0 to 1. F of u means in place of x plus y plus z, I replacing u over here. The function become log u into u to the power 1 plus 1 become square into du. So in this form, 1 by 2 log integral 0 to 1 log u into u square du, I able to reduce my given triple integral into this type of single integral. Clear? 1 by 2 integral 0 to 1 log u into u square into du. We are getting the same over here. Clear? Now next I need to evaluate this integral. The simple integral, single integral with single variable u. So we apply by parts to integrate it. Clear? So now we are using to evaluate it. So this integral I have written in this form in the last slide, 1 by 2 integral 0 to 1 u square into log u into du. This is the function. Clear? So now we integrate it by parts. For by parts, I use the rule ILATE. This log I am taking as my first function, u square as my second function by the rule. So integrating by parts, what I get, this is 1 by 2. First function as it is, log u into integration of u square, it's u cube upon 3 from the limit 0 to 1 minus integration of derivative of first function log u is 1 by u into integration of this is u cube upon 3 into du. This we are getting. Now if I look at this part, on putting the limits, if I put the upper limit, we know that log 1 is 0. So this value is taking the value 0. If I put the lower limit, I put it over here, so this gives you the value 0. So this first term over here at both the limits getting the values, taking the value 0. Yeah. The first part is 0, this 1 by 2 outside. For this part we are getting the value 0. And in this part what we are getting, look at minus 1 by 3, I can take common outside, 1 of the power of u will cancel out, giving you the value u square. And integrating now u square with respect to u, what we get? U cube by 3 from the limit 0 to 1. Put the limit, the lower limit here is 0, the upper limit is 1 itself, which gives you the value 1 by 3. This will become 1 by 3 into 1 by 3 into 1 by 2. 3 3s are 9, 2s are 18. So it should be the value minus 1 by 18 is the answer for this integral. Clear? When we evaluate it, the value will become minus 1 by 18 is the value. Clear? So this is how we apply the Dirichlet integral, Liouville's extension of Dirichlet integral to evaluate a triple integral by converting it to a single integral. Clear? So the first example for the extension. Come to the second example. Look at the next one. Show that triple integral dx dy dz upon x plus y plus z plus 1 whole cube is equal to 1 by 2 log 2 minus 5 by 16, the integral being taken throughout the volume bounded by the planes x equal to 0, y equal to 0, z equal to 0 and x plus y plus z equal to 1. Yeah. So means this x plus y plus z equal to 1 and all these three values are taking the value 0. From here, I able to find out the limits for x plus y plus z, means the values of h1 and h2. Okay. So what I write? I start that here, since each and every value is starting from 0 and going up to this plane. So x plus y plus z taking the value between 0 to 1. X plus y plus z taking the value between. So they are nothing but the values of this h1 and this will become the upper limit h2 for extension. Clear? So by Liouville's extension, what we have triple integral f of x plus y plus z, x to the power l minus 1, y to the power m minus 1, z to the power n minus 1, dx, dy, dz we have already discussed. This is gamma L, gamma m, gamma n by gamma L plus m plus n integral h1 to h2 f of u to the power L plus m plus n minus 1 into du. Yeah. So now I started with my given integral, which is again the triple integral dx, dy, dz upon x plus y plus z plus 1 whole cube is the value. Yeah. So now if I compare again now this integral with the left hand side part of extension. So these parts of x, y, z again missing in this question. What I write this triple integral, the function itself which is 1 upon x plus y plus z plus 1 whole cube into, again since the parts x, y, z missing here, I can write this as x to the power 0, y to the power 0, z to the power 0 into dx, dy, dz. Dx, dy, dz. Yeah. So writing these parts as L minus 1, M minus 1, N minus 1. This we have already done in many questions. This 1 upon x plus y plus z plus 1 whole cube into 0 is written as 1 minus 1, y to the power also 1 minus 1, z to the power also 1 minus 1. This dx, dy, dz. Yeah. So each we are getting the values L, M, N, each are here 1, 1, 1. And this is the function, 3-dimensional, 1 by x plus y plus z plus 1 whole cube. Clear? So now we are applying this right hand side part, means we are getting the h1, h2, we are getting the L1, LMN. We already know the function fu which is given to us. So by applying the extension, you have to name it over here by Liouville's extension. I now write in the form of gamma function. So what I write, this equal to L, M, N each are 1 here. So it's gamma 1, gamma 1, gamma 1 upon gamma 1 plus 1 plus 1, L plus M plus N. This triple integral converted to single integral with the limit h1, h2 which are here 0 and 1, 0 to 1. Yeah. Next is the function f of u. In place of this x plus y plus z, I have to replace this with the value u. So it's 1 upon u plus 1 whole cube, 1 upon u plus 1 whole cube into u to the power L plus M plus N minus 1. So this will become u to the power 1 plus 1 plus 1 minus 1 into du. So that's how a triple integral converted to a single integral by using the extension. What happened? This will cancel out. Here I get 1 by gamma 3. Gamma 3 nothing but 2 factorial, which is again 2 integral 0 to 1 u square upon u plus 1 whole cube into du. I left u square over here, divided by u plus 1 whole cube into du. So this is the integral which I obtain by using this 1 by 2 integral 0 to 1 u square upon u plus 1 whole cube into du. So what last I need to integrate this integral. Okay. So look at in the next slide. What we get? I get this 1 by 2 integral 0 to 1 u square upon u plus 1 whole cube into du. Now we need to integrate this. So to integrate it, just we make a substitution over here. We putting u plus 1 equal to t, so that du will become equal to dt. Now, by making this substitution, look at what is the change in limits we get. For the lower limit 0, we are getting the t equal to 1, become the lower limit. For the upper limit 1, we are getting t equal to 1 plus 1, which is 2 over here. The limit will become from 1 to 2. Clear? So putting the values, I put the value u plus 1 equal to t. This implies u is equal to t minus 1. So converting this given integral into the integral in terms of t, in place of u, we put the value t minus 1 whole square divided by u plus 1 replaced with the value t, which is t cube into dt. So integral will become 1 by 2 integral 1 to 2 t minus 1 whole square divided by t cube into dt. This is the value. Now just we need to integrate it. To integrate it, now open the whole square in numerator. I write this as t square plus 1 minus 2t divided by t cube into dt. Solving it further, 1 by 2 integral 1 to 2 t square by t cube is nothing but 1 by t plus 1 by t cube, the next term, minus 1 of the t power will cancel out, giving the value 2 by t square into dt. This is the value. So we have separated this is 1 by t plus 1 by t cube minus 2 by t square into dt. Now just I need to integrate this. I am writing this as 1 by 2 1 to 2 is the limit, 1 by t plus t to the power minus 3 minus twice t to the power minus 2 into dt. So in the next step, we integrate it. Look at what we get. It's 1 by 2. Integration of 1 by t is log t. We know. Integration of t to the power minus 3. It's t to the power minus 3 plus 1 upon minus 3 plus 1. Minus 2, t to the power minus 2 integration. This t to the power minus 2 plus 1 upon minus 2 plus 1 from the limit 1 to 2. This we are getting. From the limit 1 to 2. So I am writing this in some simpler form. This nothing but 1 by 2 log t. This will become minus 3 plus 1 is minus 2, giving a minus over here. 1 by 2 and taking this power t square. Minus 3 plus 1 is t square. Or what happened over here? This 2 will cancel out. Minus minus will become plus. This is t to the power minus 1, which I take. Sorry, it's minus 2 plus 1 hai. This is only 2. So minus 2 plus 1 give you the value minus 1. Minus minus will become plus, giving you the value 2 upon t from the limit 1 to 2. So this is the value I am getting over here. Yeah. Put the limits now. We get 1 by 2. The upper limit here is 2. I am putting this on all. I get the value log 2 minus 1 by 2 into 2 square. 2 to the 4, 2 the 8. I get the value 8 over here. Plus, I put the 2 over here, 2 cancel out, I get the value plus 1. Minus, I keep a minus over. Lower limit, I get log 1. Put t equal to 1, I get minus 1 by 2. Put t equal to 1 over here, I get plus 2 over here. This we have obtained by using this one. Now what's happening? Log 1 is 0, we all know. Okay. And solving these values, I can solve it like in over here. It's minus 1 by 8 plus plus 1 minus minus plus 1 by 2 and minus 2. This one. I get minus 1 by 8 plus 1 by 2 and minus 1 plus 2 is minus 1. Taking the LCM 8, it's minus 1 plus 2 4s are 8, 4 minus 8. So what I get? Minus 9 plus 4, यानी कि minus 9 by 8 is the value we are getting. Sorry, minus 9 plus 4, this will become minus 5 by 8 we are getting over here. So what I get, this is 1 by 2. One value I left is log 2 minus of 5 by 8, because the value is minus 5 by 8. Clear? Multiplying this 1 by 2, it will become 1 by 2 log 2 minus 5 by 16, which I need the value. 1 by 2 log 2 minus 5 by 16. That's the value. Writing over here 1 by 2 log 2 minus 5 by 16 becomes the final answer for this one. Clear? So this is how we evaluate any of the triple integral by converting to single integral and then solving it by using the extension, Liouville's extension of Dirichlet theorem. So today we have discussed most of the two important topics of multiple integrals. One is the Dirichlet theorem, Dirichlet integral, and one is its extension. And both of these are used to solve the triple integrals without putting the limits. Dirichlet integral uses only gamma function. Its extension uses both gamma function and one integral also. I mean, the triple integral is converted to single integral and then we able to evaluate that single integral. Clear? So write down its answer will become 1 by 2 log 2 minus 5 by 16. That's all for today lecture. Thank you.